Hello, my name is Odd Gurvin. I'm project manager at Norwegian Cognitive Center. Thank you for joining today. Today we are going to follow up on the 4 cases we looked into yesterday. Yesterday we looked into the strategy and business part of the cases. Today we're going to look at the technical side. A company called Computas has done a research together with Norstat, and they found that every third Norwegian company now believes that artificial intelligence is important. And also 1 of 4 Norwegian companies will start using artificial intelligence within the next 12 months. Today we're going to who already have started and implemented AI in their services. First we're going to meet Hansa Borg Bryggerier by Ken Bernes, who is an IT manager at Hansa. Welcome, Ken. Can you
Thank
hear
you.
us?
I can hear you. Can you hear me well? Can you hear me?
Yes, we hear you well.
Okay, great. Today I'm going to talk about how we use machine learning to help customers. I will actually not do any technical deep dive. I like to understand a bit what I'm talking about. Probably the most important parts of this case is also the usage. The techniques are fairly well known. So yeah. So if we go to the next slide, I come from Hansa Borg, as you said, definitely most known for all kinds of beer, but we sell other kinds of beverages, both with and without alcohol, like mineral water, soda, cider, and wine, and so on. Anyway, the example is from the pub and restaurant market, where we wanted to see whether we could use data to recommend products to this guy on the photo here to our customers. So basically, we were going from using sales agents selling by phone to self-service, a web shop. So this is business to business, professional customers. It's not open for everyone. You need a license to sell alcohol and so on. This solution has got about 2,000 customers and 400 products. And the market is alive at all kinds of hours. So it's used 24/7 every day. When they still ordered by phone, they got help and assistance with it. Like, have you considered that it's Halloween and you might need a little bit more of this or some more of that product? So when we went to the web shop, we noticed that customers were more frequently forgetting things. So as a result of that, we got extra orders. We noticed that we got customers that panicked, scared of going out of stock and so on. So we wondered if we could manage to help them by using recommendations. So a recommendation engine is pretty basic nowadays. However, there are some things that's possibly a bit unusual with our case. The typical example and primary motivator you'll find for use of a recommendation engine is to increase sales by recommending similar products, products bought together, or purchases of customers that are similar. But these customers have a much more stable purchase pattern than consumer-facing web shops. They have menus, for instance, that they don't frequently change, and if they change it, we often know about it. Also, there is a much lower volume, so the potential sales increase would probably not be that high. Also, we had a pretty good idea the width of products, to call it that the customers would buy. The main uncertainty for us was more when they would need resupply of a product. So that was defined as a time series classification problem. which also is a well-known technique, but as far as I know, is not very often used in a product recommendation context. Not a typical example, at least. So the web shop is then automatically customized for every customer, and this algorithm is important in that sense by displaying products with the highest probability of repurchase or refill. So basically for us, it's been all about the customer experience, but we still need some kind of key performance indicator. And for us, it's been about how long does it take our customers to get the job done. More specifically, to minimize clicks, time spent, and times during a week the customer need to spend ordering, to make sure that they find what they need fast and in one go. And the result seems to be working pretty well. We've achieved all of those things. Average time spent ordering is reduced by about 25%. And we also got great result in a customer satisfaction survey with regards to the web shop and these changes. So I want to end by the point that even though you or your customer don't fit the typical case for a recommendation engine, for instance, that you don't have that much traffic, there might still be a good reason to build one. And for us, that reason is to keep our customer happy, and we'll continue to use algorithm with that goal in mind. Also, at the very end, if you are a data scientist with a specific interest or love for our business, you're very welcome to contact me for a chat.
Thank you very much, Ken. Also trying to recruit people here. The next speaker is Helge Hatteland from Sonat, who has developed cutters solutions, and we're going to hear a bit about that. Thank you.
All right, so I'm going to talk today about how cutters utilizes artificial intelligence to streamline a low-tech industry. So what is cutters all about? Their slogan is to cut hair, cut time, and cut cost. But how are they able to do so? First of all, they try to increase productivity by making data-driven decisions. They want to provide better services by continuously listening to performance feedback, and also optimize efficiency by smart use of resources. Cutters is built around the Google Cloud Platform. It has several services, for instance, BigQuery database for storing data, cloud functions for code execution, compute engines for heavy computations, storage buckets for file storage, task scheduling for triggering function execution, Data Studio for visualizing data, and much more. All fully scalable and basically plug and play. At Cutters, Google Cloud Platform serves as the data source. All partners are integrated to the Google Cloud Platform via various APIs. For instance, we use Planday for shift planning, Waitfile for tracking waiting times, PowerOffice for accounting, Swish, MobilePay, Whips, and many more for transaction data. But also, Google Cloud Platform serves as a place to fetch data from, for instance, for marketing platforms. We use Facebook to target customers with smarter ads, and also Klaviyo to act upon data, for instance, when customers give a bad feedback. All right, so what can the data actually tell us? For instance, how are salons performing? Which salons met the expected utilization? Why and why not? What is the expected absence due to illness? How much should we overstaff? Which customers should we target with advertisement? Who hasn't visited in a long time? How has COVID-19 affected volume? Has cutting habits changed? The cloud functions serves as the glue that ties everything together. Each cloud function has a specific purpose, for instance, fetching data from an endpoint and populating datasets, clustering employees according to workplaces, performing simple regression analysis, and uploading results. Each function subscribes to a specific message. For instance, the message hello. Then we have the cloud scheduler, which publishes messages, which again triggers the function which listens to the message. This can be done at specific times of the day, specific days of the month. For instance, 5 a.m. every day. Doing so, we can control when, what, and how often code is triggered. All right, so what do we actually do with the data in Cutters? We perform predictions for every salon on every day. Knowing exactly how many customers to expect is key. We generate optimized shift plans according to demand, because overstaffing is waste of resources. At the same time, understaffing leads to lost potential. Predicting inventory demand, because restocking in time is absolutely necessary, and also with appropriate amounts. Customer loyalty classification. Identify which customers are unlikely to return. Predict next purchase per customer. Reach out to customers with a friendly reminder when they should return. So how is Cutters actually able to successfully leverage AI? A key point is to use managed services. The Google Cloud Platform serves as a major component. It is cost-effective. You only pay for what you use. It is highly scalable. It works just as well for small businesses as it does for large. It is serverless. You can just write code as you usually would. This allows data scientists to work with what matters, generating business value. Furthermore, at Cutters, we use few programming languages. Doing so has a flat learning curve because most people know it already. We also have utilized few people and had patience, because throwing more people on the problem doesn't necessarily solve it any faster. We always start with simple solutions. Don't spend time on something complicated. Just start with something simple and iterate. Fast feedback. The problem changes over time. Sometimes the client doesn't even know what they want until they have asked for it. And also, continuous improvement. Revisit old solutions. How can this problem be solved better now when we have access to more data? And finally, have flexible requirements. Don't be too strict with missing values. Balance time consumption with value generation. So in short, if there's one takeaway from this presentation, then it's to keep it simple. Thank you.
Thank you very much, Helge. The next out is the award-winning Mjoll with Steinar Søreide, CTO at Mjoll. How they make AI, use of AI make everyday life for journalists and video editors more efficient. Welcome.
Thank you very much. Yes, I am from Mjoll, and we have one product. It's called Mimir, and we started just a couple of years ago in 2018. Can we do the next slide, please? We are working in the media management space. We have a background from creating broadcast software, and media management is a big thing, and we saw the trends. People need to start using cloud infrastructure, which is difficult when you have a lot of big files that should either be stored or at least analyzed using different AI technologies in the cloud. AI is also a big trend in the media industry. It's quite obvious that we can save a lot of time by using AI instead of having people logging manually what's in the videos by using speech to text or face detection or object detection and other types of AI technologies. Technically, we run off the AWS environment on Amazon, and we have a serverless core, which uses all the great technologies that you just described, which takes care of the scalability for us. We launched our product in March 2019, and that was our first customer. It was a Norwegian customer, but today we have more than 25 customers spread across the whole globe, actually. And I had to include this slide. You mentioned that we did win an award, and yesterday there was a big ceremony where they gave us this fantastic award for the best product, which was given by the NAB convention, which is the biggest broadcast convention in the world. Our product is built on the serverless stack on AWS. So we are using Lambda and DynamoDB and managed Elasticsearch and the usual serverless technologies. This has kept us running and allow us to do upgrades continually without any downtime, and we have been running stable since we launched the product the first time. We actually have had no downtime on the platform. We also have some software that needs to run within the firewall of the customer. So we are also utilizing Docker containers to be able to run some software on the inside. But the cloud core is central for the system. It's storing all metadata in the cloud core. And we have a multi-tenant environment, so all the customers are using the same infrastructure so that it's very cheap for us to bring in a new customer and onboard them in the system without incurring any extra cost on our environment. We have a product which is sold on a software as a service business model. So they pay per user per month, and then the cost of AI that they are using on or via our platform is paid per consumption. This is an example from our user interface. Here we can see a video clip that has been transcribed, and the content or the voice is speaking Arabic, and we are using speech-to-text technology to get all the text from what they are saying in the video completely automatically. And we are also using translation so that we can also see the same content in English. And this makes it possible to search in your native language, or the journalists that are using the system can search, for instance, in English and find matches in spoken words that were spoken, of course, in Arabic without involving any translation manually. There is, of course, a ton of inaccuracy discussions around this, but for finding content and understanding what the topic is in the video, this automatic transcription and translation is more than good enough. This is another example where we are using face detection, where we can tell who is in the video, and we can also show that in the timeline under the video, where in the video the different people are visible, which is also very useful for journalists to get an overview of who is talking the most in a debate, or for search purposes, which is one of the main points for finding specific points in video where the people that they are interested in are talking. And of course, we can combine that with searching for spoken words so that we can give very narrow searches. Show me videos where Donald Trump is talking about fake news, and you will get a lot of hits. We are also using object detection. We're using the AWS recognition API to get the tags of what's in the videos and still pictures. So if you search for sunset, you will get many hits, and we're then getting hits within the videos, and we can show the exact keyframe of the video inside the video where there is a sunset, for instance. The AI technologies that we are currently using is quite a big range of services offered by others. And we are offering all the big ones when it comes to speech to text. And we're also using natural language processing to analyze the spoken words in a text to basically bring in the topics of the conversation. So we can categorize content into political content versus business content versus sports based on what they have been talking about. I mentioned object detection and also face detection, where we are using a couple of services. I think this is maybe the most important point I want to make today, the build versus buy. AI technology is available on many different levels. And if you get started with AI, if you start working on really low-level stuff, you can create your own neural networks. You can use libraries such as OpenCV and Tesseract, which are maybe not even categorized as AI or machine learning. And then you have the little bit higher level libraries like TensorFlow and Keras. They will require quite some work to get started. You need to have software developers that understand machine learning, and you also need training data to build your own and train your own models. This is difficult for a startup to have access to. So we went higher up in the chain. We looked at AWS SageMaker, which is offering basically machine learning as a service, where Amazon is supplying the basic infrastructure for running models and also training models. And you can even buy pre-trained models that you can run on their infrastructure. And they are also offering, of course, the compute power to run these models. And then on the highest level, you find the purpose-built services. There you have quite easy to use APIs where you can just contact a REST endpoint, and you can either download or upload media to the services, and they can analyze it. That's what we are mostly using. And we did end up we started using these purpose-built services because it's easy to get started. There's a lot of money we can save because there is a cost to using these services, which is quite expensive. For instance, the AWS recognition APIs are charging us $6 per hour material that we analyze. And that can be quite big if the data set is big, of course. But our business model is to recharge our customers for what they use, adding just a little markup on this, so that we don't have any risk in using these APIs, and our customers are using the APIs and paying for them. In the future, we might want to do cost optimization and implement our own lower level, for instance, face detection, which is not that difficult today. But so far, that has not been our main purpose. That's not what we are good at. Our background and core is workflows and broadcast media workflows. So that's what we have been focusing on. I'm going to show one other example where we have the ability to combine data from multiple AI services to provide a better end user product. The face recognition APIs that you use at, for instance, AWS, they require you to pre-register all the faces before you run the analysis. This can be a challenge if you have a big archive, let's say a historical archive from 20 years of footage that went on TV, and the cost of analyzing that is going to be huge. And if you then didn't pre-register all the faces, you need to rerun the analysis. We have managed to create a feature in our product that automatically does this even without pre-registering the persons. So, for instance, we see these three pictures where Boris Johnson is part of each picture, and some other people. and we can bring that content in, typically a lot more than just 3, and it can be videos or pictures, and then we can auto-register the person that occur in these videos or pictures in a way where the system ends up having only one person defined as Boris Johnson. So if we look at the person page of Boris Johnson, then we can see that he has 2 different pictures automatically assigned to him. And we can also see on the Appearances tab that there are 3 matching items where he occurs, which are those 3 pictures that we uploaded to the system. So this is kind of, I wouldn't call this AI, this is just algorithms and data structures that we have built by combining data from various AI services, which allow us to have a competitive advantage compared to the other big ones. So, this is just one more example from that one. We can skip that. We are also AI service agnostic. So we let our users or customers choose which AI service they prefer. So in the settings inside, as a system administrator of our system, our customers can go into this menu and choose per language which transcription service they want to use for the different languages. So what we have built as our core product is a tool for journalists and video editors. There are so many AI providers out there that do great analysis for media, such as Google and Amazon and all the ones that I mentioned, but none of them are making end-user products that fit the workflow in broadcast. So that's what we are good at and what we have done. And I think that's the end of my presentation.
Thank you so much, Steinar. The next presenter is Christian Sloper from Sonat, who is going to present a case from BKK, optimization of the heating process with use of AI. Welcome, Christian.
Thank you, Odd. Yeah, so the short title is Thermal Prediction. We're gonna spend some time explaining the business case here, then talk a bit about the technical solution and lessons I've learned in this project. So the name of the project was Robotstyring Fjernvarme, so robot control of district heating. It's done for the customer BKK. It's partially funded by SkatteFUNN. And it's done by a small team from BKK and then me from Sonat as the architect, data science, developer, and DevOps guy. So we have to talk first about incinerator. So to avoid landfills filling up, waste can no longer be stored in landfill. We have to incinerate them. So waste is destroyed. This creates heat. This heat can be used for boiling water. And boiled water can either be used to run a turbine, or it can be used in district heating. And now we don't no longer call that a system an incinerator. Now this is a thermal power plant. So in cold periods, winter, the district might need more heat. So then we burn fuel to satisfy customers. This generates 2 main decision problems. When do you use the turbine? And when do you start the burners? So problem number 1, when to start the burners. At night, people don't use as much heat. So heat is accumulated in the pipes. There's 180 kilometers pipes underneath Bergen. And this works as a giant thermal battery that gets hotter and hotter during the night as we pump in more heat. in the morning, when people start showering, people get to work, businesses start using warming their offices, this heat is then spent. So the main decision problem is then clicker problem. Yeah, as an operator, decide how we accumulate enough heat tonight. If you do nothing, you risk running out of heat, and the customer will experiencing cold houses and low temperature on the hot water. Or you can start the burners, but then you risk wasting fuel that you actually didn't need to spend. So the problem is that the operator of the thermal power plant, he has to decide this 3 hours in advance of this actually happening. So without any prognosis, the operator is very conservative, and he will use the burners more than he actually need to. The second problem, when to use the turbine. The problem here is that the turbine, so we start the turbine to generate electricity, then we sell the electricity. The startup time is 2 to 4 hours, and it requires a lot of heat. So the question for the operator now is, will there be sufficient heat available? Or will he start the turbine, then use up all the heat that he actually needed to give to the customers? So without a prognosis here, the operator starts the turbine late, and he shuts it down early. And this translates into loss of income. So obviously, both of these problems become easier if you had a crystal ball that could say, tomorrow you will use this amount of heat. So the problem for the business problem here is to generate or create a forecast model that predicts the use of heat tomorrow. So we have used Microsoft Azure, Python, and TensorFlow to do this. So we used 65,000 hours of recorded customer usage. We used weather from Yr. We engineered some features in time, especially. And then we applied neural nets based on long short-term memory. So I learned this technique in a previous project. It was super hot in 2016. But now it is outdated. And this is sort of the story of machine learning, that new technologies are released very fast and you're struggling to keep up with the bleeding edge, in a sense. I want to say one lesson learned here is that neural nets take a relatively long time to train, even with renting powerful computing power from the cloud. And I think now that I would go further if I spend more time with simpler, faster solutions like decision trees and XGBoost. We created a backend engine that continually produces new forecasts and serves them to the power plant operators. So key components for us have been Azure Data Lake. We store 66,000 data points at 1 Hz resolutions. It's very cheap, and we have had very little problems with it. We use Databricks, which is a managed Spark installation. And it was a big thing for us when we started using Delta Lake. It's very fast, very reliable. And gives us 100 times, 1,000 times faster data results. Then we used TensorFlow, especially in the first part of the project, to give us LSTM models very easily. Of course, we require a data scientist and developer to do it, but it's quite easy to get to. And later on, we also used XGBoost, which is even easier. We also had a spin-off which used mixed integer programming together with ML models to and then we used Google's OR tools. So we have on purpose chosen the big actors and managed solutions because we feel that it is more reliable and it's much easier if you get stuck to find other people that have been stuck in the same place. So the forecast model produces a forecast like this. Ja, skal vi klikke? No. Okay, but it doesn't show the actual forecast here. It's supposed to be a video that's been lost. Now we lost also that slide. So we generate a very good prediction, about 96% accuracy, given a good weather prediction, because the weather is the big driver here. So if the weather prediction is bad, then our forecast is also will also suffer, and we can't realistically improve on YR's weather forecast. So we're sort of set on that. So using the forecast model, operators are braver. They use accumulated energy more often, and they reduced fossilized fuel. Operators are more focused on using the turbine. However, the system still required very deep domain knowledge from the operator. So if I said you have to use 50 megawatts tomorrow, then that doesn't necessarily give the operator enough information to make the decision. He needs to have a lot of experience to translate this into something. So inexperienced and new operators struggle to adopt this technology. So we created a second generation that created an expert system, calculating exactly when to start, when to stop the turbine. And then as a third generation, we used mixed integer programming together with a forecast to calculate the optimal mix of fuel. This is the CAT, as it's known as. It is the expert system for turbine, and it shows a green light, a red light for starting the turbine, and also expected time when you have to start the turbine. Why did this work, the project? There's very few random variables in this system. It's pipes underground, and the main users are a lot of customers which generate which sort of distribute the variance quite well. So it has been, technically it's an easy problem, so I shouldn't take too much credit, but I'm quite proud of what we've done. Domain knowledge experts were very present and very interested throughout the project, which have been very, very important. I've been on other projects, but this was not true, and made everything much more difficult. That they're always there, always ready to ask questions about the system, have been a massive help. And we have had a willingness to challenge existing knowledge. For example, with the turbine, I, as a mathematician, was like, oh, I want to start it then, stop it then, because then we will earn 5 kroner. And then the original thought was like, well, if you stop and start the turbine a lot, it will damage it. And so we can't do that. But then we started asking questions, well, is that really true? And it turned out that no, you can stop and start the turbine without actually creating damage. So yeah, let's go for that. Let's start it more often. And for me, this has been a very personal, rewarding project because I'm a little bit concerned about the environment. So to illustrate what you can do to help reducing emissions, you can buy an electric car, and that will save you about, but you can save that will save you about, save the environment for 400 kilos a year for CO2. You can start becoming a vegetarian, and that will save 650 kilograms CO2. Or you can do ML, which will save about 250,000 kilograms of CO2 a year. And yeah, this has been just very cool that we managed to do this with mathematics and computer science. The takeaway have been that small machine learning projects can be local in Bergen and economically viable. The results appeared after 3 months of work in first generation, of course, and we have built on it on the way. The project investment costs recovered quite quickly. And also that the takeaway solution is that it has to be integrated in the customer's existing software, and this is very time consuming. You have to push it in and make it available as easily as possible. and it has to be very easy to use. So lifting as much domain knowledge into the program is very important. Use managed solutions and use popular tools. I think it's more important than using best tools. And that's it. Thank you.
Thank you very much, Christian. If you guys come in front of here, I have a few questions for you. Thank you so much for now. I have a couple of questions. And because now we heard about 4 quite different cases, all using machine learning and AI. What has been the most difficult part of these projects, Steinar?
Well, in our case, since we are using AI on a quite high level, it has been actually to compare the different providers. There are thousands and thousands of companies out there that offer AI technology and services, and comparing them is not always easy. You get a lot of data back, and doing a quantitative analysis on the data to really decide which one to use. That took quite some time.
I want to see on a technical level, the main challenge have actually been to improve the model.
Training.
Not the training in itself, but we quickly got something that was, in my opinion, very good. But then increasing this further have been challenging. So it sort of very quickly hit some sort of local optimum that was very good. And then what steps to take to go from there maybe cost more than it's actually worth. It's more, maybe was better to and we did to go to other usage of the same model than to actually iterate on the model.
And the cutters case?
For cutters, the most time-consuming process, at least, has been to integrate with all the different partners, because each integration requires specific API endpoints, mappings, and basically to fetch all the data and to clean it for usage.
Okay. One last question. What have you thought about in front of the project? This is going to be difficult, and was surprisingly easy.
Well, I would say in our case, it's been more on the commercial side than the technical side. We saw that the different providers of AI are very eager to offer their services. It's a huge competition between them, so they are actually easy to talk to. So we've had great collaboration with many of them. Here, IBM, for instance, have been helping us a lot, both technically and also dragging us into projects that they are involved in, because we fill that gap between their service and the end users, so that they can actually sell their system or service without requiring the end user to do development themselves. So I would say that was maybe the most unexpected easiness of the
suppliers and vendors wanted to help you.
Yeah.
All.
Yeah.
For me, I think the speed to actually get to the first model was surprising compared to other projects. We very quickly reached and spent a very short time to get
the first result.
The first result after we had got the data into data collection. Spent a fair bit of time on data collection in the beginning, but then the time from proper data collection to a good model was very quick, and that was surprising to me.
And for cutters?
Yeah, it's sort of this similar. Once the data was already inside Google Cloud Platform and it was cleaned and ready to go, the creating of models is fairly simple when you use popular tools that are readily built. For instance, the inventory prediction was done in a couple of hours. So building some of the models were relatively fast and easy. Yeah.
Thank you very much, all of you. Just follow Norwegian Cognitive Center on web, Facebook, or LinkedIn. There is coming a new event on not so long too. Thank you very much. Bye.